This is a demonstration of the Aristo-Craft GP40 with motor problems. This particular Union Pacific unit does not exhibit the motor problems, and of course the problems have been fairly well known as far as the motors sometimes shorting out or drawing excessive current. And so far I've had two locos that have had that problem. One was a Rock Island locomotive GP40 that actually the motors started to smoke. But in this case, this test will show a Union Pacific one here that appears to be still good. And the setup I'm using is an Aristo-Craft train engineer. It's a Crest 55470A. I just purchased it new. I've had a previous model on my under-house layout, and it started to have intermittent button problems with the transmitter, so I thought I'd buy this newer version, and I'm fairly happy with these. And I just bought the fan and put it onto the receiver here. And this happens to be, I think the Aristo-Craft calls this an Everest power supply. It's a CRE 55465. And again, the train engineer is a 55470A. And that appears to be the newest version, and I think they stopped making these now because Aristo-Craft is trying to sell the Revolution. But this is a trackside engineer, and again, I've been fairly happy with these. And then I have an oscilloscope set up here. It's a Tektronix 6465A, and I have it set up such that the first two channels, channel 1 and 2, are set in addition in invert, which means subtraction. And I did that so I can measure current by way of voltage. And this is a 1 ohm Dale resistor rated at 10 watts. It does get hot to the touch when current's being drawn through it, with the locos loading it on the track. And this happens to be the leads that go to the track power. And you can see I have the scope probes on either side of the resistor. It's a 1 ohm resistor, so that means 1 volt divided by 1 ohm is 1 amp, and so if I see 1 volt on the oscilloscope with those two channels, that means 1 amp is being drawn. Right now there's no current being drawn because I haven't actuated the controller yet. And again, this is the unit that still seems to work fairly well. And we'll run it up here and see how it responds. And the controller is set on DC, not pulse width control for this test. And the scope is set. You can see down here the bottom, the values. It's 1 volt per centimeter, and this symbol with the down arrow means the subtraction function for channel 2. So that's channel 1, 1 volt, channel 2 for the subtraction function. Channel 3 over here is set for voltage, and it's set for 5 volts per centimeter, and the sweep rate happens to be 1 millisecond. And basically what we'll see there is probably noise or the effect of the commutator rotating when current's being drawn. So I'm going to run it up now with the controller here, and you can see this is the newer version controller because it has an on-off button on the bottom on the left for on-off all, or on-off for the transmitter, and all stop, and then the so-called frequency button when you're calibrating or setting up this system. So that, as I understand it, that means it's the newest version of these train engineers. And it has an LED display for the channels that you happen to be on, and it has a total of 10 possible channels. So I set it up for channel 1. So I'm going to run it up here, and we'll see what this thing does. And you can see I've marked these. Well, maybe we can't see them too well here. I'll have to run it. Let me run it up here first. You can see when the wheels are rotating. I marked the rollers that the loco is sitting on with a black marker pen, so you can see them go around, so you can judge when the thing is starting to operate. And each of these trucks, of course, has its own independent motor and gearbox assembly. So they're independent, so theoretically one can be slightly different than the other. One of them may start sooner than the other, because there's not a common drive shaft between the two motors, like you might find in other smaller scales like HO. So I'm going to run this thing down, or stop it here, and we'll watch the oscilloscope. Again, this is the loco that seems to function fairly well. So I'm going to run it up here to about the bottom trace again is the voltage trace, so that's about 3 volts. And the upper trace here, the center line here, the center horizontal line is basically 0. And for the voltage reading, the bottom horizontal line is 0. So those are the references. And again, this will read a voltage across a 1 ohm resistor, so we can relate it to current directly. So we can see now it's drawing about 0.6 of an amp right here. And the voltage is about 3 volts, because each one of these small gradations represents a volt. And in the case of the current, each one of the larger centimeter gradations represents an amp. So we can see over here on the loco that the wheels are turning. So I'm going to back it down a little bit so when the wheels stop. Now this is the front truck, and this is the rear truck. And I haven't backed it down yet, but you can see the little rollers going on the rear truck, and the little rollers going on the front truck. So I'm going to back it down here till it appears to have stopped on both trucks. Oh, now that's because I hit the wrong bar. I hit the stop bar, but that's fine. So I'm going to run up the power here until the wheels start turning gradually. It should happen pretty soon now. I see the rear truck has started in already, and now the front one has too. So it had to overcome some initial mechanical inertia or drag within the gear train perhaps. So over here on the oscilloscope we can see the bottom trace is 3 volts, and the current in the top trace is about 6.6 amps. It's 0.6 of a centimeter, so that's 600 milliamps, or 0.6 amps. And I'm going to run it up to a little higher speed. And you can see the voltage changes, but the current doesn't change nearly as much. So the voltage is now 5 volts on the bottom trace, and the current's about 3/4 of an amp, or 0.75 is an average between the rippling effect there, probably due to the commutator on the motor. It's a DC motor with a commutator, and it's running at a notable, or reasonably low speed, but still noticeably rotating, front and rear. And notice the lights aren't on in the front, so the voltage is too low for the voltage regulator to actuate and become effective inside the loco. I believe it has a 5-volt regulator, but it'll require a little higher voltage than that for it to work. So we'll run the voltage up till when the lights just start to come on. And again, this is in linear mode with a flat DC, as we can see on the scope. There we go. So lights are coming on there. We can see now that the voltage here is about 8 volts. and the current's about an amp as an average that this loco is drawing. So now I'm going to run the voltage down, and for the sake of the test, it's probably just as well that the regulator is not outputting current for the lights, and if the smoke unit's not on, but if it were actuated, it would, I believe, run off of that regulator. Or maybe it has its own regulator, I take that back. So at any rate, I'm going to run it down and just to the point where it seems to stop. And both trucks are still, the motors are still turning the wheels. It's barely turning. And the rear is still turning. The front is still turning. And they're still barely turning. Now with it barely turning, you can see the voltage is about 2.5. So once you get it running and you back down the voltage, you can actually have it run at a slightly lower voltage, but you can see the current is around 0.8 of an amp. Oh, and I see it had stopped here. So that's probably why the current went up slightly. You can see it stopped because we're not having the back electromotive force generated by the motors. Now if I increase the value a little bit, we'll go back over here, and there we go, the wheels are just beginning to turn. So that's not quite 4 volts, maybe 3.8 volts, and we can see that the current actually has dropped because of the effect of the back electromotive force, or EMF. So it's dropped to about 0.6 of an amp at this low speed. So now I'm going to stop here and switch to the Rock Island locomotive, or one of the newer ones that I've had a problem with. So here's the Union, or the bad Rock Island locomotive, and this one sort of exhibits intermittent shorts, and the motor started to turn maybe about 3.8 volts. You can see at the bottom trace, but notice the current is much higher than the Union Pacific one. It's sitting up here at 1.2 amps roughly. So that's indicative of a malfunction, I'd say. Now I've noticed with this loco, at some speeds, the current will actually drop down. Now in this case, it's reading 1.5 amps at 5 volts, and that's about twice the current draw of the Union Pacific one. In fact, it's even going beyond that now. And if it repeats like I've noticed before, sometimes that'll actually drop down and it'll be normal. Normal, that is, compared to the Union Pacific one. We'll see if it'll do that here. It dropped down a little bit, but not nearly what I would have expected. And we can see the lights aren't on yet, so the regulator isn't functioning. Now notice how it just changed speed on its own. You can kind of hear it too. There's the rear truck, and it, maybe slightly over 4 volts, perhaps 4.25 volts. The bottom trace here, it's drawing 1.2 amps, So it's notably higher than the Union Pacific loco. Now we'll see if we can get it to the point where it seems to change speed on its own. You can kind of hear that it's hunting. But at 5 volts, the current is, you can see it's starting, oh there it did, it changed speed, and you can see when it increased speed on its own, now it's decreasing, you can see it going back and forth, and I can hear it over here hunting. As you can see, as it increased speed, the current drops to a more reasonable value. When it decreases speed, the current is increased. So either something is restricting one or both of these motors, and they're independent trucks. And they both seem to be acting kind of the same way. And again, there isn't any common drive shaft between these. So at this stage, both motors are suspicious. Now there is a possibility there's a gearbox problem in these, but given my results with the first Rock Island run and fail, it was clearly the motors. Now here you can see the current's almost 2 amps, twice as much, almost twice as much, or indeed twice as much, given the speed this thing is running at, which is fairly low. But the Union Pacific one, now you can see when it's sped up by itself, the voltage was steady at 5 volts. But the current again is this upper trace, 1 amp per centimeter, and the middle horizontal is the reference. So you can see it's jumping between 1.5 amps and 1 3/4 amps. Sometimes it may go to 2. There, you can see it change dramatically as it's hunting. You can kind of hear it hunt. Kind of hard to tell between the front and the rear if they're both working in the same fashion, or they should be independent. And it seems to me like both of these are reacting in the same fashion. So there's an outside chance there's some internal electronics like with a polyfuse not functioning right, since that may be common to both. But when I take it apart and test each truck separately, perhaps we can tell then. So that's the end of the demonstration for now.